We can solve linear inequalities much the same way we solve linear equations. We can add and subtract from both sides of the equation, multiply and divide. We can keep the symbol, the inequality sign, the same throughout the problem unless we multiply and divide by a negative number and then we switch it around. So a problem like this one, we can distribute the 7. We can combine like terms on the left-hand side. We can add 26 to both sides. And we can divide by 7 to get x is less than or equal to 6. Notice I left the inequality symbol less than or equal to the same throughout the whole problem because I never multiplied or divided by a negative number. We can represent this answer on a number line in this fashion. The solution includes 6 and everything to the left of 6. So I have a representation of in inequality notation, a representation on a number line. I can also change the representation somewhat to change my solid dot that includes 6 into a bracket and graph to the left. The bracket gets us into a notation called interval notation. Which is just another way of expressing the answer to this problem. Interval notation works like this. I'll show it with different problems to bring out more of the characteristics of it. But for this problem, the solution goes off to the left forever, off to negative infinity, all the way up to 6, including the 6 with the bracket. But it never reaches infinity, so we use a parenthesis for the infinities. So the answer, when you look at the interval notation, says that the solution set goes from negative infinity all the way to 6, including the 6 note, which is shown with the bracket. Let's look at another example. In this problem, I can distribute the negative 2. So I have 3 minus 2x minus 8 is greater than 11. I can combine like terms on the left-hand side. I can add 5 to both sides. And then I can divide by negative 2. But when I divide by negative 2, I need to turn my inequality sign around. If I represent this on a number line, because it was strictly a less than sign, x is strictly less than negative 8, I'll use a parenthesis and graph the values to the left of negative 8. A parenthesis or an open dot if you represent it with the other notation on a number line. Interval notation then would look somewhat the same as the last problem, in which the answer starts way off to the left, all the way going toward negative infinity, up to negative 8, but not including negative 8, shown with the parenthesis. So our number line representation using the parentheses and brackets translates very well to interval notation. Also with interval notation, we normally write the interval from left to right as far as smaller values to larger values. Another example. In this example, we have fractions. Like solving a linear equation, it's nice to get rid of the fractions right away. I could do that by multiplying each fraction by the least common denominator, 12. Or in other words, I'm multiplying each side of the inequality by 12. I'm multiplying by a positive number, so my inequality sign does not turn around. If I multiply 12 times x over 4, I get 3x. If I cancel down the 12 and the 6 and distribute the negative 2, I get negative 2x minus 4. And if I cancel down the 12 and the 3, I have 4 to be distributed throughout the x minus 1 to get 4x minus 4. I can combine like terms on the left-hand side. I can subtract x from both sides. I can add 4 to both sides, and I can divide by 3. My solution is, on a number line, x is greater than or equal to 0. Equal to 0 means bracket, greater than means graph to the right. And my interval notation would look like this. From 0, including 0, off to infinity, parenthesis on the infinity since we never reach infinity. And one other type of problem for linear inequalities. A problem of betweenness, we have some value between two other values, in this case the variable expression or the algebraic expression between two values. And again, I can leave my symbols the same. I need to add to all 3 parts, or do the same thing to all 3 parts of this inequality when I solve, and the only time I turn the symbols around is if I multiply or divide by a negative number. So in this case, I can subtract 1 from the left part of the inequality, from the middle, and from the right. I can divide each part by 3, so divide negative 9 by 3 to get negative 3, x in the middle, and 5 on the right. Notice I didn't multiply or divide by a negative, so my inequality signs stay the same. To graph this, x falls between negative 3 and 5, including the negative 3 with a bracket, not including 5 with a parenthesis, and graph between. The interval notation is from negative 3 to 5, including the negative 3, but not the 5. Let me give you some practice problems. Solve this linear inequality. When you're done, come back to the video to check your answer. In this problem, I want to get x by itself in the middle, so I can subtract 6 from the left and from the right. I can then divide by negative 3, but if I divide by negative 3, my inequality symbols turn around. On a number line, my interval for the solution would go from negative 2 to 5, not including the negative 2, but including the 5. Interval notation would be written as negative 2 to 5, not including the negative 2, but including the 5. So in that case, because of the division by negative 3, division by negative number, my inequality signs had to turn around. And one more practice problem for you, one involving a fraction. Pause the video, solve this inequality, and then come back to the video to check your answer. In this problem, I can do several things, but let's say I get rid of the fractions first, so I can multiply by the least common denominator of all the denominators, which would be 3. That would leave me with 2x plus 15 is less than 9. I can subtract 15 from both sides, divide both sides by 2, and I get x is less than negative 3. On a number line, parenthesis because we don't include negative 3, graph to the left, interval notation from negative infinity all the way up to 3, up to negative 3, but not including the negative 3. So again, with linear inequalities, we can solve them much the same way we solve linear equations, except we want to be careful to change the inequality sign around only when we multiply or divide by a negative number. Also in this lesson, you should have seen how to write answers for the solution sets in interval notation.